Well, in interview, you may get a very first question like, what is functional interface? Well, basically we use a Lambda to implement a functional interface. That's why you may get a very first question like, what is functional interface? Well, functional interface were introduced in Java 8. Alright, and functional interface is nothing but an interface that contains exactly one abstract method is known as functional interface. Well, consider the code snippet here. My functional interface is an interface and it contains exactly one abstract method, that is execute method. Well, as we know that whenever we define a method in an interface, by default that method is abstract, right? So we don't have to again mention the abstract keyword in a method. Alright, so just remember, a functional interface is an interface that contains exactly one abstract method. Alright, well, functional interface can have any number of default and static methods but can contain only one abstract method. Well, consider the code snippet again over here. Interface, my functional interface is a functional interface. It contains default and static methods, but it contains exactly one abstract method, that is execute method. Alright, so this is a valid functional interface. Alright, so functional interface is nothing but an interface that contains any number of static and default methods but contains exactly one abstract method. Well, interviewer may immediately ask you a question like, how we can create a functional interface? Well, we can use a Java 8 provided add functional interface annotation to mark an interface as a functional interface. Well, let's go ahead, let's create one example. Well, here I am going to create one interface. Let's call it as my functional interface. Okay, and in order to make this interface as a functional interface, we have to define one abstract method. For example, let's say void print something like this, and I'm going to pass a parameter something like message. Okay, so this is nothing but our functional interface, because functional interface is an interface, it contains exactly one abstract method. Alright, perfect. Now in order to mark this interface as a functional interface, we can use add functional interface annotation from java.lang package. Well, basically this annotation were introduced in Java 8 to mark the interface as a functional interface. Well, if you know that this interface is going to be a functional interface, then you can ignore this annotation. Alright, otherwise if you want to explicitly mark this interface as a functional interface, then you can go ahead and use add functional interface annotation. And if you try to add another method, for example, let's say void display something like this, then this will give a compile time error, because you are here using add functional interface annotation to mark this interface as a functional interface, and functional interface is nothing but an interface, it contains exactly one abstract method, right? But here we are trying to add one more abstract method. Okay, we are totally added two abstract methods. That's why it is giving a compile time error here, because functional interface contains exactly one abstract method, right? So let's go and let's remove this method, and now this is a valid functional interface because it contains exactly one abstract method. Well, functional interface can contain any number of default and static methods. For instance, let's say default void m1 is the method name, and default method contains a body, right? Let me put one sys out over here, and let's say default method. And functional interface can contain any number of static methods, right? Static void, let's say m2, and let's put one sys out, and let's say static method. Alright, perfect. Well, by looking into this functional interface, you can easily understand that functional interface is an interface, it can contain any number of default and static methods, but it should contain only one abstract method. And this is how we basically define our own functional interface. Alright, great. Well, let's take a look into the next question, that is, what is Lambda expressions? Well, Lambda expressions were introduced in Java 8. Lambda expression is an anonymous function. It means Lambda expression don't have a name and it does not belong to any class or a object. And the main purpose of Lambda expression is to implement functional interfaces. Alright, so let's understand more about Lambda expression with an example. Well, let me head over to the IntelliJ IDEA and let me create a class over here, and let's say Lambda example, and here I'm going to quickly create a functional interface. So just remember, the main use of Lambda expression is to implement the functional interface. So let's go and let's first define the functional interface over here. Let's say the functional interface name is shape, and let's create one abstract method, let's say draw. And here we are not mentioning the abstract keyword because by default the method is abstract in a interface. And let's first see the traditional way to implement this functional interface. So let's create a class and let's give a class name as rectangle. So rectangle is a shape, right? So let's implement shape interface over here, and let's override the method, that is draw method, and let's provide the implementation. Well, to keep it simple, let me put one sysout over here and let me call it as rectangle draw method. Alright, perfect. So this is how basically we write a code using traditional way to implement a interface, right? So this is nothing but a method overriding. Okay, this is a basically oops polymorphism concept. Now let's go and let's convert this oops concept, that is polymorphism concept, into functional programming using Lambda expression. Alright, so within this class let's create a main method, and now let's convert this code into a Lambda expression. So pretty simple. So let me simply copy this method and paste it here. So this is my personal technique how I convert basically a method into Lambda expression. So it is very useful, so just follow this step. So we'll get rid of this annotation, and we basically in Java we can assign a block of code to the variable using Lambda expression. So here what I'm going to do is I'm going to assign this block of code to the interface called shape interface. So shape is basically a functional interface, right? And we can assign a Lambda expression to the functional interface variable. So here what I'm going to do is I'm going to assign this block of code to the functional interface. Now let's go ahead and let's remove the unnecessary parts from this code to form a Lambda expression. Well, here is a public. Well, public access modifier does not make sense with respect to the Lambda expression, because Lambda expression is not belong to any class or object, right? This public access modifier makes sense with respect to a method or instance variable, right? So get rid of this access modifier. And as we know that Lambda expression is an anonymous function, so let's go ahead and let's remove this method name, because Lambda expression is an anonymous function and it don't have any name, right? So let's get rid of this name. Well, what remains? Void. So void is basically a return type, isn't it? And in a Lambda expression we don't have to mention the return type, because Java compiler will automatically infer the return type by looking into this method in a functional interface, right? So this abstract method has a return type void. So here we don't have to mention the void in a Lambda expression, because Java compiler will automatically infer the return type of this Lambda expression. Alright, so let's get rid of this return type. Okay, now in order to complete this Lambda expression we have to provide a arrow symbol over here. Okay, and we need to provide a semicolon at the end of this Lambda expression. Alright, and this is your Lambda expression. It's pretty simple, right? So I hope you understood how to convert a method into Lambda expression. And here you can see this Lambda expression body contains exactly one statement. So we can also simplify this a bit. So here I am going to simply remove open and close curly braces, and this is how your Lambda expression looks like. And in order to call this functional interface, we are going to call here draw method. Okay, now I am going to run this program and let's see how it works. And there we go, rectangle draw method. Okay, it means that we have successfully written a Lambda expression for this shape functional interface, and we can simply get rid of this code. Okay, and if you can compare the code over here, we have written only 2 lines of code to implement this functional interface, but in a traditional way we need to write this much of code to implement this functional interface. But here Lambda expression reduces a lot of code here, isn't it? So this is how basically we use a Lambda expression to implement the functional interface. And just remember, Lambda expression is a anonymous function, it don't have any name, and it does not belong to any class or a object. The next question is lambda versus method. Well, sometimes the beginner may confuse with a lambda and method. So you may get an interview question like, what is the difference between lambda and method? Well, method is always belong to a class or object in Java, whereas lambda does not belong to any class or a object. Alright, so whenever we create a method in Java, we should create within a class, right? On the other hand, lambda does not belong to any class or a method, isn't it? So lambda expression should be isolation to any class. And here you can see method contains these main parts. Method contains name, parameter list, body, and return type. Well, consider the example over here, addition method. Addition is the method name, int is the return type, int a comma int b is the parameter list, and return a plus b is the method body. So this is how we define a method in a class. Now let's see how we can define the lambda expression. Well, lambda expression contains these main parts. Lambda expression basically don't have name because lambda expression is anonymous function, so we no need to mention a name in a lambda expression. And lambda expression can have a parameter list. Lambda expression has a body, and we don't have to mention the return type in a lambda expression because Java 8 compiler will automatically infer the return type of the lambda expression by checking into the code. For example, look at here, this is the lambda expression. It contains the parameter list and it contains the body, and we don't have to mention the return type, and we don't have to mention the name for the lambda expression. Okay, so this is how the lambda expression looks like. Well, try to give an example whenever you get a question like what is difference between lambda and method. Well, let's take a look into the next question. Explain lambda expression syntax. Well, this question may be especially asked for the beginners because interviewer just want to check whether candidate is familiar with the lambda expression syntax or not. Okay, just try to try to write this syntax in a paper if you have paper and pen in your hand, and try to explain this syntax. Okay, so this syntax basically contains three parts. First part is lambda input parameter, second part is arrow, third part is lambda body. Well, the first part contains lambda input parameters and second part is arrow symbol. So this arrow symbol basically link the input parameters with the lambda body, and within a lambda body we can define single statement or multiple statements. Okay, so this is how the lambda expression syntax looks like. Well, let's take a look into the next question. Why to use lambda expression, or what is the benefit of using lambda expression? Well, as we know that lambda expressions were introduced in Java 8, and lambda expression facilitates a functional programming in Java. For example, if you can see the code snippet here, so this is how we use a oops concept to write the code. For example, here we have used a method overriding. It means it is a polymorphism concept, right? So we have created a class which implements shape interface, and we have overridden the method, and we have provided the implementation. So this is how we write the code using oops concept. And here we have converted this oops concept into a functional programming using lambda expression. And if you can see, using lambda expression we have simplified a code a lot, right? Only 2 lines of code we have done the job of all this much of code, isn't it? So basically lambda expression facilitates functional programming in Java. So next is to provide the implementation of Java 8 functional interfaces. Well, the main use of lambda expression is to implement the functional interfaces. For example, again consider here shape is the functional interface, right? Because it contains only one abstract method, and here we have used lambda expression to implement this functional interface. Okay, well, next is reduce lines of code. Well, consider the same example over here. By using traditional way or oops concept, we need to write this much of code to implement the interface, and by using lambda expression we need to write only 2 lines of code, right? So this is how basically lambda expression reduces the code. Next is passing behavior to the methods. Well, we can use a lambda expression to pass a behavior to the method. For example, here I will create one more method, something like private static void, and let's say method name something like print. Okay, and I want to pass a functional interface as a parameter over here, and here simply call the shape dot draw method. Okay, now let's see how to pass a lambda expression as a behavior or a parameter to this method. Okay, so here what I'm going to do is I'm going to remove this method call, and here I'm going to call this method, that is print method, and I'm going to pass a lambda expression for this method. Alright, so this is how basically we pass a lambda expression as a method parameter. Alright, so here we are assigning this lambda expression to this variable, and we are passing this variable as a method parameter to this method. And if we run this program, it should work. There we go, rectangle draw method. Alright, and here instead of assigning this lambda expression to this variable, we can directly pass this lambda expression as a behavior to this method. Okay, so this is how we write the lambda expression to simplify the things. Well, the next question is write a Java lambda expression to create a thread. Well, basically runnable interface in Java is a functional interface. So we can use a lambda expression to implement a runnable functional interface, and then we can create a thread, and then we can pass the lambda expression to the thread. Alright, so let me create an example and let me demonstrate how we can write a lambda expression to create a thread. Let me head over to the IntelliJ IDEA. Well, go to the package, right click on the package, new, and then choose Java class, and let's give class name as something like runnable lambda example, and hit enter. Now first we'll see how to write a code using traditional way, and then later we'll see how to write the same code using lambda expression. So here we'll create a class which implements runnable interface. Let's say thread demo class which implements a runnable interface, and then simply override the run method over here. Just mouse over, click on implement methods, choose run method, and there we go. And to keep it simple, within the run method we'll put a sysout and just print run method called something like this. Okay, now go to the runnable lambda example class and then create a main method, and within a main method we are going to create an instance of thread class. So let's create object of thread here, and then pass object of thread demo. Okay, and then simply start the thread here. Okay, so this is how traditionally we create a thread object. Okay, we create a class, implements runnable interface, and then we override the run method, and we provide the implementation for run method, and we create a thread instance here, and we pass the object of thread demo class, and then we start the thread. Okay, so this is how we create the thread using traditional way. Now let's go and let's see how to use a lambda expression to implement a runnable interface, and then we'll create a thread object. Okay, well, if we can go inside runnable interface source code, you can able to see runnable is a functional interface, because runnable contains only one abstract method, that is run method. And if you can see, runnable interface is annotated with add functional interface annotation. It means runnable is a functional interface, and we can use a lambda expression to implement a runnable interface. Alright, so let's go back to our class, and here we're going to use a lambda expression to implement a runnable interface. Let's use runnable functional interface reference variable to assign the lambda expression. So this is the syntax of the lambda expression, right? And simply put on sysout within a lambda expression body, and just call it as run method called using lambda, something like this. Alright, and then we need to create instance of thread over here, thread, let's say lambda equal to new thread, and then pass runnable, and then simply start the thread. Perfect. So this is how basically we implement a runnable functional interface using lambda expression, and then we create a thread object, and then we pass a lambda expression implementation as a parameter to this constructor, and then we start the thread. Okay, so let me run the program and let me show you, and there we go. So this is working as expected. Well, we can simplify this lambda expression even more. If you can see here, lambda expression body contains only one statement, so we can get rid of this open and close curly braces over here. All right, perfect. And if you can see here, we can simply pass this lambda expression itself as a parameter to the constructor. For instance, I'm going to pass here and I'm going to get rid of this statement. Okay, so this is how we can pass a lambda expression as a parameter to the constructor as well. If I run the program, it should work. And there we go. All right, so this is how basically we use a lambda expression to implement a runnable interface, and we pass that lambda expression to the thread object and then we start the thread. All right, I hope you understood how to use a lambda expression to implement a runnable interface, and how to create a thread, and how to pass a lambda expression. All right, great. Well, let me explain you why do we need a default methods in interfaces with an example. Well, consider in your project you have this kind of hierarchy, like you have interface and you have multiple implementation classes which implements the interface. Okay, so consider in our example we have a shape interface. It has a draw method. So basically draw is an abstract method, and here we have rectangular, square and circle. So these are the three implementation classes of shape interface. Now we have a requirement to add one or more methods to the interface. Then what will happen, basically the implementation classes should have to implement those newly added methods. For instance, let me add one method over here. Let's say m1, and m1 is an abstract method. So all the implementation classes have to override this method and provide the implementation, isn't it? But my requirement is like I need to implement this method only in rectangle and square. I don't want to implement this method in a circle. All right, but this don't allows us to unimplement this method in this circle implementation class, because this is abstract method and we have to override this method and provide the implementation. Otherwise we will get the compilation error like this, isn't it? So in order to deal with this kind of issue, a default methods were introduced. So once we use a default method, what will happen, basically the default method will be automatically available to all these implementation classes. We don't have to override the default method. Okay, for example, let me quickly create a default method over here. Default void m1. So this should be default. Okay, let me put one sys out and let's say m1 default method, something like this. Now this m1 default method will be automatically available to rectangular, square and circle. Okay, so in this way the default interface method will resolve this kind of issue, and default method will automatically available to all the implementation classes. Therefore we don't need to modify the implementation classes. Okay, so in this way backward compatibility is neatly preserved without having to refactor these implementation classes. So this is why the default methods were introduced in the interface. Okay, so default method is mainly used to preserve the backward compatibility. Okay, so once we define the default method in the interface, that default method will be available to all the implementation classes. We don't have to add the abstract method and forcefully implement in all the existing implementation classes, right? So I hope you understood why do we need a default methods in a interfaces. Well, Java method references are basically introduced in Java 8. Well, method reference is used to refer a method of a functional interface. It is basically a compact and easy form of Lambda expression. Well, each time when you are using Lambda expression to just referring a method, you can replace your Lambda expression with a method reference. Well, basically we use a method reference to replace the Lambda expression. Well, for example, look at here the code snippet over here. This is the Lambda expression just to refer a method. For example, system.out.println. So println is the method, out is the object. Okay, so this Lambda expression is just to refer the method, that is println. So we can easily replace this Lambda expression with the method reference, and here you can see the syntax of converting the Lambda expression into method reference. So basically we remove this Lambda expression and we provide a double colon here in between object and function like this. So this is basically a method reference. Okay, here we are just referring to the method using method reference. Alright, so just remember, each time when you are using lambda expression just to referring a method, you can replace your lambda expression with the method reference. Well, why optional class? Well, before optional class we were writing a lot of null checks, right? For example, consider we have an employee class. It contains all these fields, right? And if you can see this code snippet over here we have a get employee method. So consider this get employee method is retrieving the employee object from the database, and consider we have a email which is null in a database. Okay, so here if we call a get email method on employee object, then this returns null because employee does not contain email id. And if we call to lowercase method on null reference, then this definitely will give the null pointer exception, isn't it? And in order to avoid this kind of null pointer exceptions, we are adding a null checks, right? For example, employee not equal to null, and within that employee dot get id not equal to null, and again employee dot get email id not equal to null. So here we have just added a null check for these two fields. What if we have a requirement to add a null check for other fields, right? So basically we need to write a lot of null checks over here. So adding this kind of null checks is not a good practice, isn't it? So we have to provide some solution for this. That is where the optional class were introduced. So optional class basically help us to avoid writing null checks, and it will also avoid to produce the null pointer exception. Now let's see what is optional class. Well, Java 8 has introduced a new optional utility class in java.util package. This class can help in avoiding null checks and null pointer exceptions. Well, if you can see this diagram over here, optional class, it acts as a single value container that either contains a value or does not. We will discuss one more very important Java interview question, that is difference between collections and streams in Java. Well, as we know that streams are introduced in Java 8 and collections were introduced in 1.2. And in this video I am going to demonstrate each and every difference between collections and stream with an example. Alright, so that you will understand better. Let's go and let's take a look into the first difference. Collections are used to store and group the data elements in a particular data structure like list, set or map. Well, as we know that we use a collection to store and group the data elements, right? On the other hand, streams are used to perform some complex data processing operations like filtering, matching, mapping stored on the data such as arrays, collections or input-output resource. Well, we basically use streams to perform some operations like filtering, matching, mapping, and we create a stream from different sources like arrays, collections or input-output sources. Well, let me demonstrate this point with an example so that you will understand better. Well, here I have written a piece of code to demonstrate this difference. Here I have created a list object using ArrayList implementation class, and list is basically a collection, and we store basically data elements in the list, right? And on the other hand, you can see here stream. Well, first we have converted list into stream because we basically create a stream from the collection or array or any input output resources. So in this example, we are creating a stream from the list, and then we are performing some filtering operations using filter method on this stream. Okay, so here basically we are filtering apple from the list. Okay, and then finally we are collecting the result. It means that streams are used to perform some operations like filtering, mapping, collecting the result, etc. Streams are not used to store the data elements. Okay, collections are used to store and group the data elements. On the other hand, streams are used to perform the operations like filtering, mapping, collecting the result. In this example, we are using filter method to filter apple element from the stream elements, and again we are using collect method to collect the result in a list. Okay, and then finally we have printed this list. Alright, so let me run the program and let me show you the output. And here you can see, here we have used stream to perform filtering operation. Okay, so filtering operation here basically we are filtering apple element from the stream. Okay, and here is the output. Apple is filtered from this stream. Okay, so basically collections are used to store and group the data elements. On the other hand, streams are used to perform the operations like filtering, mapping, collecting the result, etc. Well, let's take a look into the next difference. You can add or remove elements from the collections. On the other hand, you cannot add or remove elements from the stream. Well, as we know that in collections, we have add and remove methods, right? We can use them to add or remove the elements from the collections. On the other hand, you don't see any methods like to add the elements or remove the elements, because we don't use stream to add or remove the elements. Okay, we use stream to perform some operation. For example, let's consider the same example over here. Here we have created a list object using ArrayList implementation class, and here we are using add and remove method. Okay, so basically ArrayList class provides add and remove method to add the element to the list and to remove the elements from the list. So this is how we can add and remove elements from the collection. On the other hand, you don't find any add or remove APIs or methods in a stream, because we cannot add or remove elements from the stream. Okay, stream is used to only perform some operations like filtering, mapping, okay, matching and collecting the result, etc. Alright guys, one more important to note here is that whenever we create a stream from the different resources like array, collections, input, output resources, and if we change the stream, then its source does not change. For example, here consider list is a source for a stream, because here we are creating a stream from the list, and whenever we do some operations like filtering, mapping and matching operations on stream, then list could not be modified. For example, let me print the stream over here. Before that, let me remove this statement, and here I will print the list. I will just use for each here, and then I will just print each element from the list, and here I'm going to use method reference. Okay, perfect. So what we have done, basically we have created a stream from the list and we have modified this stream. Okay, and whenever we modify stream by using filtering, matching, mapping, etc., then the source, that is list, should not be modified. For example, let me run the program and let me show you the output. Okay, so here what I will do, I will put one new line. Okay, let me run the program again. Yeah, there we go. You can see here the output. So result, so this is the output of the stream. Okay, and apple is filtered from this list, so you can see banana, mango, orange. And then fruits is the list, and I have printed fruits over here, and you can see fruits list contains 4 elements. Even though we have performed some stream operations, that is filtering on fruits, but the source, that is list, is not modified. It means that whenever we create a stream object from the different sources like arrays, collections, input, output resources, and perform some operations on stream, then the source should not be modified. In this case, the list is not modified because list is a source for the stream. Okay, so this one is the important point to note. Well, let's take a look into the next difference. Collections have to be treated externally using for loops. On the other hand, streams are iterated internally using for each loop. Well, as we know that we can iterate over collections like list, set, map using for loops, right? We can use for loop or for each loop. On the other hand, on the stream, we can use for each method. I mean, we don't have to use for loop to iterate over stream elements. Stream have its own iteration mechanism. For example, you can see here the code snippet. We have created a list and we are iterating over a list using for loop as well as for each loop. And you can see here the stream elements. I mean, stream provides its own internal iteration mechanism, and yeah, it exposes for each method, so we can use for each method of stream object to iterate over stream elements. Okay, and if I run this program, it should work properly. Okay, great. It means that collections have to be iterated externally. On the other hand, streams are iterated internally because stream provides internal iteration mechanism and we don't have to use loops to iterate over stream elements. On the other hand, collections we can iterate using for loops. Well, let's take a look into the next difference. Collections can be traversed multiple times. On the other hand, streams are traversable only once. It means that we can loop collections multiple times. On the other hand, we can loop streams only once. Okay, for example, so look at here the code snippet. Here we have created a list and we have added elements to the list and we are iterating or we are looping this list multiple times. First by using for loop, second by using for each loop. It means that we can iterate collections multiple times. Okay, we can traverse collection multiple times. On the other hand, you can see here stream. So first we have created a list and we have converted a list into stream, and then we have performed some filtering operation, and then we have stored this filter method result into a stream because filter method returns a stream, and then we are traversing over a stream by using for each method. Okay, and if I want to traverse this stream again here by using for each loop, for each method, then this will basically gives the error. It means we can traverse stream only once. If we try to traverse it again, then it will give the error. Okay, for example, let me run this program and let me show you the output so that it will clear to you. And there we go. You can see here the error stream has already been operated upon or closed. It means that we can iterate or loop or traverse stream only once, and in case of collection we can traverse collection multiple times. Okay, well, let's take a look into the next difference. Collections are eagerly constructed. It means whenever we create a list, set or map, all the elements are computed at the beginning itself, right? On the other hand, streams are lazily constructed. It means that in a stream we have two types of operations, intermediate operations and terminal operations, and until and unless the terminal operations should called, the intermediate operations cannot be completed. For example, look at here, we have created a list and all the elements are computed at the beginning itself. Okay, this list is created eagerly. On the other hand, you can see a stream is created lazily. Okay, because here you can see based on the condition the stream is created. Alright, it means that collections are created eagerly. On the other hand, streams are created lazily. Alright, so these are the few notable differences between collections and stream, and I have explained each and every difference between collections and stream with an example, and I believe that you understood all these differences. In the interview, make sure that you will explain all these differences and try to give examples. Alright, great. Thank you for watching this video. I will see you in the next video.